Hi everyone, and welcome to the day at the office of a DevOps engineer. I'm just gonna say a few things. This is a YouTube stream, as you already figured out. So there is a delay between what you hear and the chat. So if you write down a message, I'll probably see it I'll see it immediately, but there will be a delay between that and the things that I'm saying, right? So sometimes I'll even ask if anyone has questions or something like that, and then there will be some silence because there is delay. Feel free to ask questions during the session. The recording will be available probably tomorrow after I'll be done editing it, and the recording will be available using the same link as you used for this live stream. And a link to this presentation, because it's a presentation with Google Slides, so it will be added to the description of this stream when the session is over. Okay, these are like a short intro. First of all, I hope you can see me over here. I put myself over here because unlike my other webinars, other sessions that I have delivered, I think it is relevant to see me because this is not a technical session. It's gonna be a very wide overview of what I'm doing on my day-to-day work, and we're gonna speak more about that. So who am I? So my name is Meir Gaba. You can see me, this little guy over here, and you can contact me via my work email, LinkedIn account, whatever. I work at ProdOps for almost a year, ProdOps.io, and I am a DevOps consultant or DevOps engineer. It depends, on the customer what they want. And previously, I worked at NICE for something like 4.5 years, and I was the training operations manager over there. Mostly dealt with creating automations and improving processes all around training. Now, why am I telling you this? Usually I won't talk about NICE because it's not relevant to DevOps. Why am I telling you where I came from? Because this webinar is intended to anyone who ever wanted or thought about moving to DevOps or trying to get into DevOps jobs or stuff like that, because it's possible. You only need to want it and you need to know how to learn. Okay, that's the main thing. I think the main idea is you need to learn a lot. Okay, so who is ProdOps? What's ProdOps? It's a company based in Tel Aviv, Israel, London, and Miami. Established on 2013, and we got tons of projects that we're doing up to date. Unified and rebranded in 2018, and probably if some people know us from before, then it's DevOps or DevOps Pro. Some of our clients. And something that I forgot to mention, what we do, okay, I'm like, okay, this is ProdOps, but what do we do? So we define architectures for customers. We help customers to select the relevant tools that they need, like if it's, and I'm gonna throw some buzzwords over here, right? So Terraform, Kubernetes, Drone, Ansible, Chef, Jenkins. So all of that, we assist customers who work in the development industry. When I say develop, I mean it can also be the health industry. Okay, as long as you have servers and you need help on how to maintain them, how to design them, how to make sure they are loading right, you contact us and we help you. Okay, I'm gonna talk more about DevOps, and then you understand what ProdOps does. So some of our customers, and what we're gonna talk today. Explain to me what is DevOps like I'm 5 years old. It's not going to be absolutely like 5 years old, because I am going to assume you know some stuff on the development and operations industry, but not too much, okay? So it's almost like a 5 years old. Processes and tools, usually what we use as a DevOps engineer, a lot of times we do some pipelines, so I'm gonna talk about some pipelines. This does not necessarily mean that this is only what we do, or this does not necessarily mean that all of the DevOps engineer do that. Essentially, each DevOps engineer does a different thing. I'm gonna show you what I'm doing. I think it's what I'm doing. I think I got lucky that I'm doing a bit. I got a broad spectrum of projects that I did multiple things, but some people, if there are some DevOps engineers out there or some developers out there who are listening to me right now, and they're gonna hear out what I'm gonna say about DevOps, and they will say this is not what DevOps engineer is doing in my company. This is because each company embraces DevOps differently, and we'll talk about that more. Okay, I won't dig into that right now. We're going to talk about type of architectures. So even if you don't know anything about the cloud, anything about virtual machines, we're just going to talk briefly about architectures. We're going to talk about keeping it secret, keeping it safe, which means secret, security, and networking, making sure that there are no vulnerabilities in the environments. And of course, after all of that, we're also going to talk about I like it, how do I begin my journey? Because if some of you want to start being DevOps engineers, you want to know from where to start. So here you go. And last but not least, in the end, I'm going to do a demo. Now, I said that this is going to be 30 minutes. I mean, this is what was written in the description. So it's going to be 30 minutes. I'm not sure it's going to include the demo. The demo is more a technical demo. So if you're just here to listen what's DevOps and what do you do on your daily basis, then this up to here will take 30 minutes. And I think this will take maybe 5 or more. Okay, so if I see people hanging and here, then I'll keep on to the demo. Okay, so let's start. Finally, let's start. So what is DevOps? So I'm just going to start with a very basic sentence. DevOps, in my eyes, okay, I'm going to be very, very specific because eventually a lot of companies do it differently, is improving processes all around the areas of development cycles and operations. What do I mean by that? Because it is going to be for 5 years old, right? It's got to be simpler than that. So think about it like this. We have, and you know what? I think it will be even easier if I do it with my board. So we have people over here. People over here. These are the developers. And the developers are writing some code, okay? All day long, they just write some code. When they finish writing their code, which includes features and stuff that you like, let's take Instagram, okay? So everybody will be connected to what I'm gonna talk about. So let's talk about Instagram. A developer developed a new feature, okay? First of all, we need to make sure that this feature is not breaking the whole application, right? You don't want to wake up someday and realize that Instagram is down, especially if you're using it, okay? So the developer is writing his code, and then he needs to send it to the operations team. Okay, it's ops. This is why it's DevOps. Sends it to the operations team, which usually includes system administrators and people who usually deal with infrastructure and architecture. And they know, it's magic. They know what to do with the code, how to assemble it, how to build it, and what to do with it. So it will be deployed eventually, so you can see it on your Instagram application. Now, this was very, very, very short. This is not exactly what's happening. It's a very, very, very high level, because what's going on over here, like there are tons of processes that are going inside those departments. But the main thing over here is that DevOps shouldn't be there shouldn't be I didn't fix it. Okay, DevOps is a culture. Okay, so eventually you wouldn't need a DevOps engineer if everybody would follow along the DevOps culture, which means know how to get things done right, test your stuff. There are a lot of things and a lot of definitions of how to do DevOps exactly how you're supposed to do it. But if we're talking about DevOps engineers, because this is what we're here for, then the DevOps engineers are sitting, we can say, over here, and sometimes even playing the roles of everyone. They like know a bit of everything, but mostly know about the whole process. Okay, that's the main idea. They know about the whole process, and they make sure that there won't be a fight between developers and operations, because developers, when they develop, they do stuff on their local machines. So a developer has his own computer, and they code, and everything works on the computer. But when they send the code to the operations and tell them, okay, this works on my computer, now upload it to the website, upload it to the application. So operation takes it and they're like, okay, let's upload it, and then they get an error. And what do they do? What do you think they do? Immediately they go back to the developer, they tell them, listen, this doesn't work, I need you to fix it. But developer says, but it works on my machine, why doesn't it work in the cloud? And then starts the whole, blaming issues and stuff like that. So DevOps, as part of being a DevOps engineer, you are here to avoid all of this, blaming stuff. Okay, just no blaming. You make sure that the processes now will go through the presentation. You make sure the automating the integration, merge hell, okay, I'll get into that, and deployment, which is usually build, test, and deploy. This is what we are doing. So we are automating the integration. So what I just talked about, this, we are automating this whole process. Okay, we don't want to get people involved. The least people involved, the better. And what is merge hell is what I said about features. Remember, I told you a developer is developing a feature, and you don't want it to break the whole application. So you avoid the merge hell. You take the feature of the developer and you want to merge it to the whole application. So by doing the automating the integration, you are avoiding this breaking changes each time somebody adds a feature. Okay, so it's also important to do that. Great. Hold on. Okay, so design architecture. This is not something that all DevOps engineers do, but usually it also comes with that. If you need to design an architecture which is reliable to endure heavy loads, which is reliable when you need to do a disaster recovery. So think about it. Instagram, okay? Let's take Instagram for this whole session. So think about it. Now, this is Instagram, right? This is the application. And today, Kim Kardashian posted a new perfume or whatever. So now you have tons of users, and I'm not gonna do more users, but think about it, that you got now, 1 million, 1,000, 10,000 users connecting at the same time to Instagram. So how do you deal with that? Because if you have a constant number of servers, let's say I got 3 servers, even if you don't know what's a server, think of it as something that serves your application. Okay, so even if you don't know what it means, think about it. Let's say I got 3 servers, and three servers serve, let's say, can serve 1,000 people. Okay, so what happens if 10,000 people are connecting to my application? Probably it's gonna fail. Okay, so how do I avoid that? So this is something that DevOps usually do. It's called auto-scaling. Okay, and then when you do that, when 10,000 people connect, suddenly more servers are coming up. But this costs more money. Okay, so what am I doing with that? But when the load is over, all right, we can check the load on our servers and then kill them and get back to the original 3 servers that we have. So if we have a constant use of 3 servers and then we got a peak, we know that we're gonna get a peak, so we can do something which is called auto-scaling and then create more servers. When the peak is done, servers are going down. So this is what's called scaling. Okay, scaling and dealing with heavy loads. Security, again, it's part of the architecture, keeping passwords and secrets safe and mitigating vulnerabilities. But if I want to be specific for the architecture, I don't want my 10,000 users to be able to access my databases. Think about it, the databases contains all of the usernames, user information, and all of the important details. Okay, everything that is important usually is stored in database. All of the details. All right, photos are probably stored somewhere in a storage service, but the details about the users and about everything of the app is in a database. So let's draw some database over here. Okay, let's call it DB. I don't want my users to be able to directly access my database. So as part of that, a DevOps engineer makes sure that due to network security, there's no access to the database from external users, but there is access from the application itself to the database. Okay, so that's like a direct connection, but we don't allow users directly access our database. Just one simple example. It can go much deeper. I'm just trying to keep it simple so people will really understand what it means. And flexible, applying changes is easily. Usually, on your day-to-day life, you create something. It doesn't have to be even a code or something. It can even be a Word document or an Excel sheet. And then you say, okay, I need to change something. And when you think about the change, you have a headache because you're like, oh my God, it's going to take so much time to apply this change. I think I'm going to give up. I'm not going to do this change. So as part of designing the correct architecture, we also make sure, when I say we, I say DevOps engineers also make sure that the architecture is flexible enough. So if I want to scale horizontally and create more servers, or I want to scale vertically, which means upgrade my current servers, so it's flexible enough. This was only about auto-scaling, what I just said. But think about flexible can even be, I want to add a feature, okay, going back to Instagram, I want to add a feature, and this feature includes another server. So think about it. What is it going to be a problem for Instagram to connect to this new server? If it is, it's a problem. So we're not going to add features just because it's impossible to do so because somebody designed the infrastructure bad. So it's very important to design it flexible and to easily apply changes. And of course, we always make sure that processes are transparent, which means I always know if this server failed, and I know if this server is utilized or not, if it's being used or not. And I always know if users are trying to attempt my database, even if it's not possible, or are trying to hack my application. So I'm always monitoring everything. All of the processes are transparent, including this process, this, what I just wrote down here, this pipeline, all right, what you see over here, it's a process, right? Code, build it, do something with it, and then deploy it to the application itself, all right? So this whole pipeline, I always know what's going on with it. So this is why I wrote down, making processes transparent. We always know when and where a process failed to complete. Other than that, we also take advantage of CLI, which is a command line interface. So if you see those cool movies with hackers, open up the terminal and do some code. So other than writing some code, there is something which is called CLI. It's usually CLI is a tool. Okay, a tool can be AWS CLI, Terraform CLI, but because I know who's my audience, I'm sure you're not well familiar with that. So I'm not going to dig up into CLI. I'm just going to say a few words about YAML files. Okay, what you see over here. So as part of being a DevOps engineer, you love writing down. I love writing YAML files. Why? Because instead of going to the application, let's say I want to go to Facebook. Okay, I will again show it over here. Let's clean it up a little bit. Let's just scroll down to get a, okay. So let's say Facebook. Let's say I want to send a message to Mosh. Okay, that's the name, Mosh. Mosh is the user I want to send a message to. So if I log into Facebook, Facebook, as you know, looks like this, something like that. I need to go to my friends, right? And then go and search for Mosh. And click here and click here and click here and click, do many clicks and then send the message. See, everything is done with the mouse over here, right? So instead of that, I might be able to use a CLI tool, okay, a CLI, which means open up my terminal and then, let's say we have a Facebook CLI and then run some commands over here, and instead of doing it with the user interface, I'm doing it with code. Why do I want to do that? Because it's faster, because I can automate it. Why did I talk about YAML files? Because configurations for servers are can be maintained in YAML files. It's a simple file, okay? It's just a file, but this file can contain configurations, and this allows us to create infrastructures easily instead of doing it from the UI. Okay, so I hope that was clear enough. So now, because I said it's gonna be 30 minutes, so I'm gonna just go through real quick about stuff that, a few examples of what customers asked me to do for them, okay? And again, this can vary. This can change between even my teammates. Okay, so my teammates might say I have never done it, and a DevOps engineer in some other company can say I've never done this. But this is like a general concept of what we do. Okay, so pipeline. One of my clients said I need a pipeline that builds, tests, and deploys my serverless framework application. So one of my clients used serverless framework. Maybe you don't know about it, what does it mean, but they needed a pipeline. So as DevOps engineer, it was my job to create this pipeline. Great. This is how I did it. Okay, I'm not going to dive into this because I'm taking into account that we are not so technical over here. So I'm just going to go through the examples. I need to create an isolated environment on demand per user. So I did some solution with Kubernetes. The whole idea over here was when a user gets into the application, okay, of my customers, then they get their whole environment, their whole developing environment of their own, and it should be isolated from all of the other environments, because you don't want one user to be able to connect to other users' environment. Okay, so doing so, I was able to do it with Kubernetes. For example, if you ever heard about this buzzword, JMeter, for example, another application that can do automation testing. One of my clients told me I need to do a load test of 30,000 users per second. So they wanted to see, remember I gave you the example over here about the load. I don't think you want to know if your servers can take the load on real time. You want to know if they can take it, you want to practice over it. So my client asked me, I need you to make sure my servers can take 30k users. All right. Some more examples, don't worry, you can see it's 3 out of 3. Some more examples, I need to create a GitHub secrets for GitHub Actions. So again, because we're not too technical over here, my client needed to do something very redundant, something that you don't want to do, and you had to do it manually from the user interface of GitHub. Okay, so think of GitHub as Facebook. It's just a website. It's not a social network, but think of it as a website. All right. So if I'm on GitHub, so my client didn't want to click here, click here, click here, click here. It was too annoying, and he had to do it for 100 repositories, which is like his code base. Okay, so it's too much work, and I created for this client a tool. Okay, I created a tool which can do it from the CLI. Remember I told you about the CLI? So my client used the CLI, used the terminal, wrote some code, and he was able to do that. I need to burn down the office real quick, so I called 911. I just put it here to make sure you are with me. Okay, so if you are alive, it's a good time to just send a message in the chat just to make sure you are here. Secure. I want to protect my dev and staging environment. I'm gonna say a word about that. Usually your application wouldn't be in one server. Okay, you don't hold just your production environment. Usually you have at least one more environment where you do all your testing and stuff, where you check everything is working. Just like I told you about the load testing, we did it on the staging environment, and only then we pushed it to production. Okay, so this is why we create those dev and staging environment. And okay, it's good to see that you're here. Thank you. And here I also wrote, only my team should have access to these environments. So think about it. I just told you development and staging environment should be available only to developers, right? You don't want your customers to be able to access your backend, your dev and your staging environments. You want them to access only your production environment. And if someone here has, some OCD, or it's hard to understand because you see a lot of stuff over here, so let's just clean it up so this example will still be relevant. Okay, you don't want your clients to access your dev and staging, so they asked me to protect it. Great. Network, I want my database to be accessible only by the web server. This is the example that I gave you about Instagram. Okay, no need to go about that. Processes reminds me of the pipeline that I just talked about. It's really great to see you guys just, finding out. I've never seen this weird emoji with those three fingers, but whatever. A cool thing about DevOps is that you can create a pipeline. Again, it's all about automating the stuff, making it work right. Okay, so build when a commit occurs. If it's the first time you hear the word commit, it just means a developer over here committed some code, pushed the code from his computer to the shared repository where the whole code base is stored. Okay, this is a commit. So when a developer commits, okay, pushes his code, then someone added a feature, right? So after someone added a feature, we want to build this, we want to build the whole application, okay, or maybe even only this feature to check that only this feature is working. And this means we need to trigger a build after this commit, after another build or after another test happened, and this is called multiple pipelines or multiple steps. Think about it this way. I wrote some code. I don't want to manually write a command which says build the code and then run a command which says test the code. And maybe sometimes my application is so big and is so heavy that it can't even run on my own computer. So the cool thing about doing some pipelines as a DevOps engineer is that you create and automate the process. So you say, okay, some code was pushed, and then you automate a process that tests this code and then maybe even adds some more features or environment variables or any other stuff to this code, and then pushes it to staging, stuff like that. So you can trigger more and more and more, and after you build and test and do whatever you want, just like we talked about over here, then you can promote it from staging to production. So by now you've just learned about very, very high level of the development cycles and the operations and what they do, from learning about being a DevOps engineer. So recommended tools for creating your first pipeline. And again, since it's not super technical session, then you can just go after this session, go and learn about those cool tools. These ones are free. These ones are AWS, Amazon Web Services solutions, so you can check them out also. And now this is gonna be, you can see I got only 3 minutes, and again I'm in the middle, though it's gonna be short, so I'll try to be brief, but this is cool. Okay, the types of architecture is cool. So back in the day when you wanted to create a server, wait, what's a server? You remember I talked about servers over here. We don't know what it is, but eventually it can be a simple computer, okay? Just like your own laptop, your laptop can be a server, all right? So instead of putting laptops somewhere, you can rent a virtual machine and put it somewhere in the cloud, okay? When people say the cloud, so this is the cloud, right? You put some computing power, not in your home, not in your offices, and you can rent it, all right? Some businesses, you can see over here that are down, used by companies that have on-premise resources. So some companies, because of regulations, think of health companies that they store health data about people, then they don't want it to be in the cloud, so they might need to purchase big heavy machines that will store those virtual machines. So eventually a virtual machine can run on your machine or can run in the cloud. So a virtual machine, instead of installing stuff on my personal computer, if I want to check something, what I can do is I can run some hypervisor, okay, which is something that hosts virtual machines, and I can run a virtual machine on that. Now let's think about something. If I want to install Python or Office, okay, let's go very, very, very simple. If I want to install Office, Word, PowerPoint, whatever, I need now to create a virtual machine, get inside this virtual machine somehow, and then install Office. So instead of that, and I'm just giving a very, very plain example. So instead of doing that, we can also use something which is called containers. Okay, so maybe if you heard about the buzzword which is named Docker, and Docker, on its own is a lesson. Okay, so I'm not gonna teach about Docker over here. I'm just gonna talk about a few things about Docker. Docker is, you can think about it as a process. Okay, so what I can do, let's say I want to break down my application to multiple processes. Now you might think, what do you mean break down your application? But breaking down my application, let's say I got this feature and this feature and this feature and this feature, and I want to break them down. Why would I want to do that? Because it's easier to deal with smaller pieces of code and smaller pieces of processes. It's easier to scale them. It's easier to do stuff when you break to small pieces instead of having like one big structure of an application, right? Okay, so Docker containers allows that. So let's just read real quick what's happening over here. So this is how it all started, and still relevant today. People still use virtual machines, even though it was the beginning of this whole cloud and how to host applications. It's still happening. Okay, this is the most common knowledge, because usually if you know what you're doing on your local machine, you'll probably know what to do on a virtual machine. Okay, and as I said, used by companies that have on-premise resources. Now, Docker containers, so cloud-based companies tend to shift from virtual machines to containers. And as I said, why is that? Because it's easier to manage. Okay, it has a moderate learning curve, so it's not the most common knowledge. You need to learn about it. Not everyone knows about Docker. And it's easier to maintain and utilize. And again, you can learn about Docker. There's a whole workshop about it. And I'm just gonna put aside what I just talked about, virtual machine containers. So these are two types of architectures. I can say the most common ones maybe. And the new guy in the hood, okay, is serverless, which means I am not managing my infrastructure at all. I am just telling a cloud company, okay, like Amazon, right, like AWS, I'm telling them, I need this and this and this and this, please bring it up. I am not dealing with the infrastructure. When you deal with virtual machines, you need to tell them, okay, I need 4 gigabytes of RAM, 3 CPUs, blah blah. When you deal with containers, you also need to limit the containers to tell them, okay, this container needs 2 gigabytes of RAM, 2 CPUs, blah blah. With serverless, you also need to define what you want. Yeah, you also have those limits that you need to define, but still you don't need to maintain it. You don't need to do maintenance. Okay, maintenance means download updates, do the auto scaling. You only need to define it. You don't need to maintain it. Okay, so it's easier. The only con that I can see in serverless, because I use it a lot, but it's harder to understand the costs. It's easier to know how much it costs to work with virtual machines. Why is that? Because cloud companies tell you, okay, machine of type A costs, $10 per hour. So it's quite easy to understand how much money we're going to spend. You just need to know how much time you want to run this machine. Containers, they run on virtual machines, okay, and I don't want to get into this, but you can also run them with managed services and blah blah. But serverless, you really need to understand how much each process takes, okay, how much CPU it needs for each process. So it's harder to understand. It's easier to utilize because you can allocate a fewer resources, but it's harder to understand the costs because you don't know how many times this process was invoked. You can figure it out, you can monitor it, but it takes more work to know about that. Okay, so this is the new guy in the hood. This is what most people know about, maybe even you know about it, and this is like the most trending. You can even see it in Google Trends. If you search for, you compare between Docker, virtual machine, and serverless, you can see over here the Docker is crazy. Okay, good. And because we are out of time, and I can still see the same amount of people are here, and I'm shocked. So I'm just gonna continue. Okay, and for those of you who, I know if it's not enough, then remember we have this as a recording. So I'm just gonna keep on going. This should be a video. I'm not sure you can hear it. I hope you can hear it. Let's see. This is just Gandalf from Lord of the Rings saying, "Is it secret? Is it safe?" Because, and keep in mind, many times, not all DevOps engineers, it's not like a job definition. Many times DevOps engineers are required to mitigate vulnerabilities. But which, what are, good, you can hear it. So, what are vulnerabilities? So we talked about a few, networking, you want to protect, your database in a private I don't want to say the curses, subnet and stuff like that, but you want to protect your services in the network. You want to bring up some firewalls. You want to deal with, I'm not going to get into that. You want to deal with the principle of least privilege, and I think this is something you should know even if you don't know a line of code. The principle of least privilege says before allocating permissions, first of all, start from the lowest permissions and only then add them. People usually tend to say, okay, I got a new employee, let's give him administrator access, and then God knows what happens next. Okay, so if you want to use administrator access, you can do it. Okay, if you want to provide administrator access and check your access, you can do it on dev and staging, maybe. Still not so recommended, but do it on dev and staging. But in production, we'll probably never give high level of permissions. Okay, so it's the principle of least privilege. Access to relevant entities, avoiding committing them in a Git repository. So we don't want to keep secrets. What are secrets? These are like passwords. Okay, passwords. You don't want to keep your secrets in your code, because then if too many people have access to these secrets, who knows what can happen, especially if it's an open source. Okay, think about it. If it's an open source and it's just out there, you don't want to keep your secrets, your passwords, where anyone in the world can get them. Okay, so it's our job, as for some of us as DevOps engineers, to make sure that you don't do that. And if it does happen, we need to make sure that we trace it. Okay, so we can do some scanning. There are code scans to check if we can find those secrets in your repositories. And VPN, I wrote it down because some of you in their day-to-day work, in their job, if you work remotely, you need to connect to a VPN. Why? Because this only then you can access your company's portals. Okay, so if you have this HR portal that you can access only from home, if you are connected to the VPN. When you are in the offices of your company, you are already in the private network of your making your private network. Sorry, I lost it. Okay, so if you're in your offices, you're already in the virtual private network of your office. But if you're at home, you need to connect to a server. So some DevOps engineer take up or create the VPN server that you will be able to connect from home. So just to put it this way, just to be clear, good. This is you. Okay, now you're a girl. Okay, you even have a skirt. Alright, great. You work from home. You need to connect to your work. And you cannot access the HR where you can see your salary and whatever from home, because then everybody in the world would be able to access this system and your company protects it. So when you go to work, everything is okay, but when you're from home, you connect to something which is called the VPN, Virtual Private Network, and this server, a few customers asked me, please create a server for me so my employees will be able to connect from home. Other than that, you can also create it to protect other servers and services, but I talked too much about it, so let's move on. And more, because we can do a lot of stuff. Okay, so I like it how I begin my journey, and this is the last slide. Okay, I think I'll save the demo for another meetup, because I think it's gonna be an overkill, especially because I know the audience. Right, so for newcomers and developers, right? So for newcomers, if you want to start thinking about going on being a DevOps, or maybe if you want to recruit a DevOps engineer or stuff like that, you should learn Bash scripting or Python, or even get crazy and go and learn Golang. Why am I aiming to these specific languages? First of all, you'll be able to see, if you search for a job as a DevOps engineer, you'll be able to see that there is a requirement in knowledge of scripting languages. Now, why is that? Because with scripting languages, you can automate stuff, as we talked about the CLI. Remember? Hold on. Going back. Remember I talked about the CLI, the terminal? So if you learn about a scripting language like Python, Golang, I won't even say Golang is specifically scripting, but Bash is commonly used, so you should learn that. Great. take the self-study lab of play with Docker, and I think this is amazing, especially if you don't know anything. So I would even put it above this. If you don't know anything, you just want to play with Docker to understand what are containers, which is amazing. I think you'll find it lovely. You can click on the link over here. It's a free workshop. Okay, everything is online. It's great. It's easy. There are a lot of docs, so you can just learn about what is Docker over here. You can learn about how to build a WordPress website, and I gave you need to create an AWS account for this. Okay, the Amazon Web Service account for this, and you'll just learn, what is hobbyist developer. I aimed for you, so it will be easy. All right. Next on, you can create a static website, which I think I also gave it to a link to AWS. This is more it's more advanced than doing this. Okay, so if you think about doing stuff, do this, not this. Do this only after you know what you're doing. And if you're a developer or maybe a newcomer that just wants to dive in, you can create a new GitHub repository and add a pipeline to this repository. Okay. The link will be available. Okay, so the link to the presentation will be available in the description once I finish this meetup. Okay, and I'm gonna say a few words also about this presentation because you'll find it very useful. You can complete the Terraform getting started tutorial. If you wonder what's Terraform, sounds crazy. Terraform is used for infrastructure as code. So you always hear me saying about it. I don't want to work with the user interface because then it means I need to do it manually. But if I do stuff automatically or maybe maintain them in configuration files, and then I can apply those configuration files easily on development, staging, and production, so I'll probably use Terraform because it will help me create infrastructure, okay, as code. Instead of going to the UI, I will do it by writing down configuration files, which is much easier. And you can do this also. And by the way, how I started, I took the AWS. I will show you. It's funny because it's not in the DevOps journey, and you'll hear me talking about. You hear me saying AWS. It's because it's the biggest cloud provider out there, and they got a nice free tier program that you can join, so you don't need to pay even $1 when you want to try some stuff. So you can just check it out, if you hear for the first time what's AWS. Anyways, I took this exam. Okay, it wasn't easy. It took some time to learn. In the speaker notes, of this presentation, there is a link to a blog post. I will just show you 1 second. To my blog post of how I studied for the AWS Solutions Architect certification exam. So if you want to take this exam, you can simply read down my blog post and then see if it fits for you. I recommend for the Solutions Architect, but as you can see, if you want to go to the DevOps engineer, I'm looking over this. So why did I take the architect? Why didn't I take the operations and developer? Why did I take this one? It's because I had the least knowledge in this. So I have when I began my journey, I had some knowledge about development, some knowledge about operations, but I had no knowledge at all in the architecture. Okay, nothing. So I had to learn from scratch. So in doing these certification exams gave me some baseline. And it's also good, if you want to get into a job, sometimes they write down optional certification by AWS or whichever cloud provider you work with. Okay, so that's it. Okay, it didn't take 30 minutes. It took 43 minutes. I am here if you have questions. The blog post, as I said, it's gonna be, you'll see a link to the blog post. I will show you. So once you have the link to the presentation, okay, you can read now my speaker notes. I will show you. See here? So it's in the speaker notes. So I'm just gonna say one thing about the presentation. This presentation is not just for me, so I wouldn't consider it only for delivering this session. You can also use it for information, because I wrote down, I didn't say most of the stuff over here because I know that if you get the presentation, you'll see. Let's just go back to the beginning. So this is what I'm saying to you, and I just want to show you there are a lot of stuff, written down over here that I wrote down, so you'll have more knowledge, more information. Okay, what's a pipeline, Kubernetes, if you heard about kubeless, I don't know, some references. So when you get this presentation, make sure you go over the speaker notes, okay? Because you can get more information, and again, this was just a brief knowledge of what I'm doing at my day-to-day work. So if you have any questions, I'm here. If not, then have a good day. So I'm waiting for questions. Okay, great. So have a good day, and see you next time. Bye, everyone. Wait, regarding the requirements of doing some degree, I'd say for any work it's good to have a degree. I do have a B Science, but I did a B Science in industrial engineering, not in computer science. So if you think about that, I had luck. Okay, one of my colleagues in my current company in the ProdOps.io just thought that I might be suitable to be a DevOps engineer. They gave me a challenge where I needed to learn a lot of stuff. Okay, tons of stuff. And after I learned all of that stuff of creating a pipeline from scratch, I was able, they were like, okay, so let's do some more technical interviews, but this was it. Okay, so I think it's also based on, if you come with no background at all, it's also about the opportunities that you get. Okay, so it's mostly, peer-to-peer, talk with people, connect with friends, but it's important that you do have some background in developing. And as I said, regarding the presentation, it's going to be available in the description in a few minutes. Okay, so we're done, guys. All good? Any more questions? Okay, so from the silence, I'll take it as a no. So thanks again. Okay, hope this is the real last time. So thanks again, everyone. And now I really mean it. See you next time. Okay, bye.